Hello everybody. So we are going to do the transformation of a reflection today. So a reflection is more kind of like a flip or like a reflection. So when you're doing a reflection, you want to think about where you're reflecting across. So in this first problem, we say reflecting across the x-axis. So I find my x-axis. This is the x-axis. And I like to think of my line of reflection to be like a mirror. So the closer our image is to the mirror, that's the closer the new image is going to be. The further away it is, the further my new image is going to be. So really I just got to see what is the space away each point is from this line of reflection. So J, I went up 1, 2, 3, 4. So J prime, I'm going to have to just go the opposite direction. 1, 2, 3, 4. And that's going to be J prime. Don't forget to label it. So J prime I see is now at 1, 2, 3, 3, but now I went down, so -4. G, I see, okay, I had to go up 1, 2, 3, 4, 5. So G prime, I'm going to go down 5. 1, 2, 3, 4, 5. That's G prime. Should have went in order, sorry. So if I look at that, that's going to be 8, -5. M, I see I had to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. So from that line, I need to go down 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's M prime. So again, my prime is letting me know that this is my new image. This is the original. And that's going to be at 5, -9. And then I'll just connect my dots so I can see the same image. So that's that reflection. Now my rule is saying, okay, is there a rule that I can use to say it's going to be the same way every single time? Well, I should notice x comma y is the same, but my x is still x, but I had to change the sign of my y. My y's became negative. So this isn't saying that y is always going to be negative, because if y started off as a negative number, then a new one's going to be a positive number. So this means that you change the sign of the y. So x stays the same, but your y value changes. So we go to this next example. We can kind of make a guess. If I'm reflecting across the y-axis, this is my y-axis, I can assume that it's going to have that same effect, but maybe instead of the x being the same and the y changing, it'll be opposite. So we'll see. So again, if I'm reflecting across my y-axis, I need to see how far away is each point from it. So J, I had to go 1, 2, 3. 3 to the right, so now I'll go 1, 2, 3. 3 to the left. That's the new point, J prime. So I can see that this one's at -3, +4. M, I had to go 1, 2, 3, 4, 5 to the right. So now I go 1, 2, 3, 4, 5 to the left, and that's M prime. So M prime is at -5, +9. G, I went 1, 2, 3, 4, 5, 6, 7, 8 to the right. So now I gotta go 1, 2, 3, 4, 5, 6, 7, 8 to the left. And that's gonna be G prime. So that's -8, +5. Connect them. And that's a reflection across the y-axis. Now and again, what do I notice? Well, the x and y are still in the same spot, but now my x has changed sign. So that's -x, comma, y. So again, it's not saying that x is always going to be negative. It's saying you're going to have to change its sign. So if it's positive, it becomes negative. If it started off as a negative, then it's going to become a positive. That y value is going to stay the same. Now, with y equals x, it's kind of hard to do this reflection if you're going to just like use the graph. So like when I'm reflecting across my x and my y axis, I tend to count more than I do use my rule because I'm good at counting. But here I don't want to count because you got to kind of count diagonally and it's kind of like hard. So I just think if y equals x, then basically my y is my x and my x is my y. So my rule for this is x comma y becomes y comma x. So the only thing you have to do when you reflect across the y equals x axis, the y equals x line, I'm sorry, that's that dotted line right there, you flip the coordinates. So 3, 4 becomes 4, 3. 5, 9 becomes 9, 5. 8, 5 becomes 5, 8. So my x becomes the y because x equals y, and the y becomes the x. So all I had to do was flip that order. So again, that's a lot easier to think of. So I'd rather use my rule here than I try counting. So j was at 3, 4. J prime is going to be at 4, 3. M prime is going to be at 9, 5. 9, 5. And G prime is going to be at 5, 8. So if I were to reflect across y equals x, that's what it would look like. So when you're doing a reflection, again, wherever that line is, basically we're going to say if you can fold across that line, you're going to get the same image. So when you fold across the line, like if I put ink all on that triangle and then I folded it, that's what I'm going to get when I folded across that line. So when I folded across my x-axis, this is where it will land. If I folded across my y-axis, this is where it will land. If I folded diagonally right here across the y equals x, this is how it would land. Okay? So now we go to the back. Now we're reflecting across y equals negative x. Again, it's the same thing, kind of like similar to the one before, x comma y. Well, they're saying flip it. Flip your x and your y. But it says y becomes a negative x. So not only do you flip it, but they both become negative. So again, it doesn't mean that they're always going to have negative signs. That means you're changing the signs. So if one was positive, now it becomes negative. If they were negative to start off with, that would become positive. So 3, 4 is going to become 4, 3, but I got to change their sign. So negative 4 coming negative 3. 5, 9, negative 9, negative 5. 8, 5, negative 5, negative 8. So not only do I flip the order, but I change their signs. Okay. So again, so J prime is going to be at negative 4, negative 3. And again, with this one, I find it a lot easier to use my rule than I'm trying to count using my graph. So when it's across the y equals x or y equals negative x, I'm going to use my rule. Negative 9, negative 5. And then negative 5, negative 8. That's negative 5, negative 8. So that's G prime. So again, make sure you label your points and then you connect it. Make sure you double check that you put it in the right spot. And that's how it would be. So if I were to fold across this line right here, that's where my image would land. Now these last two examples is kind of the same as like what we did before when we reflected across the across the x-axis or the y-axis. The only thing is that you're at a specific spot. So this says x equals 1. Now this kind of confuses some people. They think it's like y. They want to say this is y something because it's going up or down. But here, the reason why it says x equals 1, because it doesn't matter where I'm at on this graph, x is always going to be equal to 1. So at this point right here, x equals 1. At this point right here, x equals 1. So any point on this line, x will be equal to 1. I also like to say it crosses my x-axis at 1. So where is it crossing my axis? Well, it's only crossing the x-axis. At what point is it crossing it? 1. So x equals 1. So when you have a vertical line, that's always x equals. Wherever it crosses your x-axis, that's what it's going to be equal to. So if I'm reflecting across x equals a number, then again, just like when we did when we reflected across the y-axis, I want to see how far is it from this line. And then I count the space. So j is 1, 2 to the right, so I need to go 1, 2 to the left. No rule for this, you just count. M, 1, 2, 3, 4 to the right, so I go 1, 2, 3, 4 to the left. G, 1, 2, 3, 4, 5, 6, 7 to the right, so I go 1, 2, 3, 4, 5, 6, 7 to the left. And again, remember, you are moving from this line of reflection. So I'm not worried about the axis anymore for this because that's not what I'm reflecting over. I need to use the line that they told me. So I am counting from this line right here. Again, if I were to fold across that line, that's where my points are. J is right here at -1, 4. M is at -3, 9. And then G is at -6, -5. I mean -6, 5. Okay. So you do the same thing with the y equals a number. Again, y on this line, y is always going to be equal to 4. It doesn't matter what point you choose on this line, your y is always going to be equal to 4. If I look, it's only crossing my y-axis. Well, where does it cross my y-axis at? It crosses it at 4. So y equals 4 is this line right here. So I need to say, okay, well, how far are they from it? So j is exactly on that line, so j prime is going to be on that line too. So j prime is the same as j. M, I see I had to go up 1, 2, 3, 4, 5 from this line, so I go down 1, 2, 3, 4, 5. That's M prime. G, I see I went up 1, so I'm going to go down 1. So again, the line that I'm reflecting across is like my mirror. I see how far away my image is from that line, and I just go the opposite direction. If I were to fold across that line, that's how it should fit. M is right here at 5, -1. And then G is at 8, 3. And those are my new points. So when you're doing a reflection, if you can count, you can do a reflection. Remember, when y equals x or y equals -x, it's easier to use your rules for those one than it is to count. But on the other ones, it might just be easier to count it to see where the spaces go.